Okay, here are the questions you asked about. So on question two, it says for the hyperbola, if b is equal to 8 and c is equal to 17, then find the a value. And so I have basically the standard form of these equations and then also the formula for finding a, b, and c, the relationship between a, b, and c, I guess I should say. And so what I want you to notice here is that a is always the first denominator and b is this, or a squared is the first denominator and b squared is the second denominator, right? And so one of them is going to be positive and one of them is going to be subtracted, right? And so the one that's positive is going to have is going to be parallel to the transverse axis. Okay, so if you see right here, this one is parallel to the x-axis, the transverse, and then on the second one where we flip flop it, then right here it's parallel with the y-axis. And so, anyways, that's going to help us with some other questions you had. And then also, I think finding the center, you're probably pretty good with that because it's the same for all these different conics with the h and the k. But here, the formula or the relationship between a, b, and c is different for the different conics. But here's the relationship for hyperbolas, and it's actually identical to the Pythagorean theorem. A squared plus b squared equals c squared. So you just need to plug in c and your b, and then you should be able to solve for a without any problems. Um, okay, so let's look at the other ones you sent. So then you asked about number 6, and it looks like you actually already answered it. So let's see how you did here. So it says the transverse axis is parallel with the y-axis. Well, it's going to be parallel with whatever variable shows up first, right? Whatever one is right here. And it is y. So yes, very good. So that one is correct. That's good. Okay. Then the next part's asking you where the center is. And so you said the center is at -4, 2. And once again, that's correct. Very good. So it's the opposite, right? It's the value that's with x. Basically, it's what makes this go to 0. And so -4, if x were -4, it would make this go to 0. And if y were 2, it would make this one go to 0. So you're good on that one. And then it says the a value is 5. Remember, the first one, this is always your a squared, and this is your b squared. And so 5 squared is 25. Very good. So you've got number 6 correct. On number 7, it looks like you only answered one part of it, and it looks good to me. It's correct. I'm going to go ahead and let you answer the other two parts. I don't really think you should have any problems with that. Um, and then the last one says determine the vertices. And so uh, the, the, the vertices are going to be the a value, or you're going to use the a value to find the vertices from the center, right? So before you can do that, though, there's a lot of cleaning up to do. And so let's see, my y squared is positive, so I already know my transverse is going to be parallel with the y-axis because of that. But all right, so I'm going to take the y's, and I'm going to factor out the 4, and that's going to leave me with y squared minus 6y, and then I'm going to have to do the completing the square process in just a minute. And then on the next part, can be a little tricky. I'm actually going to need to factor out -49. So I'm going to pull out a -49, and that should turn this to a positive x squared, and that should turn this to a positive 2x, and then plus blank. And so you can see that if I were to redistribute that -49, that would give me the -49x squared and the -98x. Um, okay, and then that -209, I'm going to go ahead and add 209 to both sides to get it kind of on the other side. Okay, so now we got to do the completing the square process, which is taking half of this and squaring it and putting it here. So half of this is -3, but then squared is +9. But really, that 9 is getting multiplied by 4, so that's really a plus 36. So I'm going to have to go ahead and add 36 to the other side to preserve the equality. Then on my second one here, half of 2 is 1. 1 squared is 1, so I'm going to put a 1 here. And then that's really a -49 though, so I'm going to have to put a -49 over here. And then now it's time to kind of start cleaning some stuff up. And so let's see, this is going to be 4 times, we can factor this into y minus 3 times y minus 3, or we're going to put it as y minus 3 squared. Then minus 49 times, let's see, this is going to factor into x plus 1 squared. And then here, let's see, when we add this together, let's see, we're going to get 245 minus 49, I believe it's going to be 196. And so then here we're going to divide everything by 196. And it should simplify fairly well with the 4 and the 49. It shouldn't really give us too much trouble. So let's see, that right there would reduce to 1 over 49, or we're just going to write this as y minus 3 squared over 49. And then on this one, let's see, the 49 and the 96 can reduce to where we're going to have x plus 1 squared all over 4, and then equals 1. Okay, so let's see, we have to find the center before we can find the vertices. And so let's see, the center is going to be at -1, 3. Okay. And then remember to find the vertices. It's full. There's a couple things you got to realize here. It's parallel with the um, y-axis, the transverse that intersects the two vertices. And let's see, my a value is actually going to be equal to 7. So, I mean, we can also do a little visual here if we need to. So let's see, -1 up 3. So there's the center, right? And the transverse goes through this, right? And so the a value, you just have to add and subtract that to the y value, and that will find those vertices for me. So I'm going to have one at -1, 10. So it'd be up here, and then you subtract it, and the other one would be at -1, -4. Should be somewhere down here. And obviously it's not perfectly to scale, but just to give you a little visual there. And let's see. You actually have that selected. And so you should be good to go on this question on number 8. Looks like you already have it correct, but maybe you just wanted to double check, and it looks good to me. The last thing you did ask about the adjusted intervals. So I'm going to go ahead and pull something up on that we can look at. Let me see. Okay. These are from the notes, and I kind of wanted to work on a basic one here, because if I start with a really hard one, that might be a little bit harder to really grasp. So this first one right here, 7's not too bad. Now, you don't want to overthink the adjusted intervals. All it is whatever's occurring to the angle that's going to be evaluated, you just apply that to the, oops, it's not responding. You just apply that to the your interval. Okay, so I just went ahead and switched over. So yeah, so we're going to multiply those by 2. So we're going to adjust my intervals. So now I'm going to be looking for solutions anywhere between 0 and 4 pi. And all that really means is 2 revolutions within 2 revolutions of the unit circle. So I can go around twice and look for where sine's equal to 1. Well, sine's equal to 1 right up here at pi over 2. And that's it. So going around the unit circle, going around once, that's 2 pi, and then going around again, that would be 4 pi. So what I can do is I can actually, I go here, and I find one at pi over 2. That's one of my solutions, right? And then I can basically go all the way around a second time, so basically adding 2 pi to this. But adding 2 pi to this, I'm going to have to get a common denominator. And so 2 pi is actually the same thing as 4 pi over 2, right? So I'm going to take pi over 2, and I'm going to add 4 pi over 2 to that to do an extra revolution because that's within my adjusted interval. And so my 2 pi, I put it as 4 pi over 2, so I have a common denominator, so I can add this together. So 1 pi plus 4 pi gives me 5 pi over 2. And so that would be another solution. So that would be another solution would be 5 pi over 2. So those are my 2 solutions. Now, those are solutions for sine of theta. The problem is if I actually plug these answers in, it's not going to work because that 2 right there is going to double it. And so what would happen is I'd end up getting sine of pi if I were to plug this in right here, because 2 times pi over 2 would be sine of pi, which then would give me 0, which would be incorrect, right? So what we have to do is we adjusted the interval. Now we have to adjust our answers backwards. Now we have to undo what we had done on the interval. On the interval, we multiplied by 2, so now we're going to divide by 2, or dividing by 2 is the same. That's the same as if we were to multiply by 1/2. And that might make our life a little bit easier if we just multiply by a half, because basically you're just going to multiply your denominators by 2. So my actual solution set would be pi over 4, because 2 times 2 is 4. And then my other solution would be 5 pi over 4 when I multiply that by 1/2. Now, what I want you to notice about that is now both of these answers are within that original interval, my original interval. So really doing the adjusted intervals, it's kind of a trick. It kind of it's supposed to like kind of break this into smaller steps and make your life a little bit easier. So you adjust the interval, but then you have to adjust your answers once you get them. And it's very helpful for when they get more complicated. So this was kind of like an introductory problem right here. Um, and so, and if you were to plug it in, I'll show you that it works. So if you plug in sine of 2 times pi over 4, what happens here is that 2 times pi over 4 would turn into sine of pi over 2, which does indeed, it does equal 1. So it does work. And the same thing would work if you plugged in 5 pi over 4. It would also work for you. Um, One other thing I'll mention, it didn't seem to come up very much in these examples, but it is possible that you could get something like sine of theta divided by 2, and then you have your interval from 0 to 2 pi. And so what you'd have to do on adjusting your interval is you would divide both of those by 2, and so your new interval would be from 0 to pi instead. And then once you find your answers, you'd have to undo that division by multiplying all your solutions by 2. But if I recall correctly, in the notes, that doesn't come up very often. That's something that we cover in trig, though, in our trig class. But I don't really recall it showing up here. Um, so anyways, I've got some other videos on the adjusted intervals because I've had other questions about that. And so I will send you a copy of that too.